All right, let's look at the topic 1 study guide. So we are going to graph a few functions on this first page and state some different things. So this first one, we are going to graph an absolute value graph, and then we are going to state the domain and range. All right, so I know that the parent function, y equals absolute value of x, has a vertex at 0, 0, and you can make an xy chart if you want to. When x is 1, y is 1. When x is negative 1, I take the absolute value of negative 1, I get positive 1, and I know that it makes it v, so I don't need to go any further than that, right? And then this rule says take the graph left 3, because remember I take out x plus 3 and I set it equal to 0. So this tells me left 3 and then down 2. So I go left 3 to negative 3 and down to negative 2, and then I'm going to follow the pattern. My slope is 1, so I'm going over 1, up 1, over 1, up 1 to make the v. All right, so my domain is how wide does my graph get? It just keeps getting wider and wider, doesn't it? So I can put negative infinity to infinity or all real numbers. My range tells me low to high. My lowest point is negative 2 and my highest point is infinity. If there had been a negative in front of this absolute value, it would have flipped it over to look like this. And let's say it had the same vertex, then my range would be negative infinity to negative 2 bracket, low to high, right? But this is my domain and range for this picture. All right, so this graph, it's y equals 5x minus 12, which is a line, right? There's no absolute value, there's no squared. So this is a line, the slope of 5, and the y-intercept of negative 12. So I'm going to start at 0, negative 12, and I'm going to slope this. I'm going up 5. Notice these are counting by tens. So, and over 1. Oops, I went over 2, didn't I? So let's go up 10 and over 1, or over 2, I mean. So I went up 10 over 2, and that's still up 5 over 1. I'm going to go ahead and go up 5 and over 1. So I just go over half because we're counting by 2s. Okay, so there's my line. The question asks, on what intervals is this function positive and what intervals is it negative? So remember, positive means I'm above the x-axis. So here are my x's that give me y values that are above the x-axis. So I keep going with that line. And then here are my y values that are below, and my x values that push me below are right here. Get that a little bit better here. For some reason, it's a little off on the tracking. Okay. All right, so we need this point where the line crosses the x-axis. That would be an x-intercept. So I want to set this equation, put 0 in for y, because I want a point on the x-axis. So I know x-intercept, no matter what my graph is, line or whatever, parabola, I put 0 in for y. So 0 equals 5x minus 12. I'm going to add 12 to both sides and divide by 5, and I get x equals 12 over 5, or 2.4. And I put that on the calculator, 2 and 2/5, or 2.4. All right, so that's where this is. So that means it's positive where it's yellow, right? That's above the x-axis. So from 2.4 to infinity, any x I choose over here, I'm going to get a y value that's above the x-axis. So it's positive from 2.4 to infinity, and it's negative from negative infinity to 2.4. So negative infinity to 2.4, just following along this blue. Any x value I choose here, my matching y value is down there. All right. For what values is this function increasing and decreasing? So we're going to graph this, and I'm going to kind of switch it around. Leave the sign in front of absolute value of x. So we know absolute value of x, we've already graphed one. 0, 0, 1, 1, negative 1, 1, 2, 2, negative 2, positive 2. All right, but what is this going to do to it? We're moving down 2. And we have a reflection over the x-axis. So I have a flip. All right, so I'm going to flip it over and down 2. So my vertex is at 0, 2. But now I'm going down 1, right 1, down 1, right 1. All right, so there's my graph. Now we're thinking roller coaster with increasing and decreasing. So look, reading it left to right, I'm increasing and then decreasing. All right, we're talking about that with x, right? So my graph is increasing from negative infinity to 0. That's where it stops, right? So increasing from negative infinity to 0. Parentheses on all that, and then decreasing from 0 to infinity. So all through here, every y value I pick, as I move to the right, it's going to be lower and lower and lower to get to this line. Okay. All right, so we didn't get this page yesterday, so I'm going to skip that. But you're welcome to work it. I'll go slow so you can work it, so you can pause the video and work these problems if you want to. All right, let's get to this one. Okay, so they're asking me to write the rule. Here's the information, and here's my parent function. So f of x equals, I'm going to start like this, right? So I need to go left 6. So it just says x squared over here. I've got the squared out there. Left 6 means x plus 6, down 5, minus 5. Right, so that's my rule. If it also said vertical stretch, let's say it said vertical stretch of 7, I would put a 7 in the front. All right, I know ours didn't say that, but I'm just saying if it did. Or if it said a reflection, it would be negative. So things that happen vertically, vertical, are on the outside of my graph. Left and right movements, left or right movements are on the inside of my function. I think I said graph, but function. All right, number 9. All right, this is going to be a piecewise function because we have 2 different things going on. He makes $10 an hour for up to 40 hours. So x is going to be hours. So $10 for every hour up to 40 hours. So x is less than or equal to 40. So any hours 40 or less, he's just going to make $10 an hour. If he works more than 40 hours, he's going to make 1.5 times his hourly pay, or $15 an hour for each hour over 40 hours. So he's going to get the 400 from the 40 hours because 40 times 10 is 400. Plus, he's going to get $15 an hour for every hour over 40. So this is going to be x is greater than 40. So if he works 41 hours, he's going to get 1 hour at $15 an hour plus the 400. So I need to take the hours that he works and subtract the 40 out because he's already getting that pay. All right, so those are my 2 equations, right? Then I'm going to graph that, and I used f of x and x for my variables instead of what they told me to use. All right, so from 0 to 40, I'm going to graph 10x. So at 40, I'm at 400. And at 0, I'm at 0. So I'm graphing this line, and it's a continuous function. It's not discrete. And that's a closed circle. and then I'm going to pick up this line at 40 also. So if he works 40 hours, 40 minus 40 is 0, I get 400, and then I'm going to graph the rest of it from there. So let's say he works 50 hours, right? So he gets 10 hours at $15, it's 150. So I'm making a t-chart and finding f of 50. So 400 plus 15 times 50 minus 40, 400 plus 15 times 10, 400 plus 150 is 550. So I'm going to 50. So this is counting by 8 fours. Each tick is 4. And I'm at 50, so I'm going halfway. So 50 and 550. A little bit higher than that. So the slope is a little bit steeper, and it should be, because our slope here is 15, and on the first one it was 10. Right, so that's what the graph looks like. It is a continuous function. All right, here's the sequence. So number 10 wants to know, is it arithmetic? And if so, what's the common difference? And it is arithmetic. I don't need to find the sum. I just need to show that it's arithmetic. And so it's a yes, and we're adding 7. All right. Find the 110th term in the sequence. So I'm going to say A 110 equals, so remember I'm using this, A sub n equals A sub 1 plus D times n minus 1. That helps me find the value of a term number. So my first term is -7. My common difference is 10. I want the 110th term. So -7 plus 10 times 109, and you should get 1083 when you throw that on your calculator. All right, a recursive to an explicit. So I'm going to use this same formula. So I have A sub n equals 45 plus my common difference, because we're going to subtract on each term. So -5, I'm going to go ahead and change this to -5 instead of plus a negative. So -5 times n minus 1. So that's my explicit definition. I can clean this up, and I end up with -5n plus 50 as my equation. You can definitely leave it right there if you would like. We didn't get these yesterday, did we? So there's a piecewise to graph. This one, when you see it on the test, will be, you can use your graphing calculator or Desmos. So remember, when you practice on this one, on Desmos, put y equals -x plus 3 in the first block on Desmos, and put absolute value of 3x plus 9 in the second block on Desmos, and see where they meet. Where do they cross? So look for intersection. Okay, we have this one. All right, so use the graph. What is the solution of the inequality? All right, so we are targeting this. So I just want to think about this for a second without looking at any pictures. -x squared plus 16 means I'm moving my graph a U shape up to 16, and it's flipped over the x-axis. So I'm going to flip this over the x-axis and then move it up 16. So that means it's going to be up here at 16 and look like this. All right, so just from knowing those transformations, I can eliminate these two graphs. Now let's look at the question. The question says, where is this graph above greater than 0? So above the x-axis, where is it positive? So this graph is positive or above the x-axis here, which means my x values are between those two, right? If I choose an x value here, my graph is up there. If I choose an x value over here to get to the green part, right, my graph, I have to go down to get to the green part. So I'm between these two x-intercepts. Notice it's not equal to, so I want to stay between those two x-intercepts. So let's see what we've got. This one says x is between -4 and 4. This one says x is less than -4 or x is greater than -4. That would definitely put me below the x-axis. So I want between -4 and 4. So when I choose an x value, I get a positive y value. So B is my solution on that one. All right, the sum of the arithmetic series. So we're going to use S sub n equals n times a sub 1 plus a sub n over 2. So to find this, I need the number of terms. I need the first term. And I need the last term. Value, not number. I need the value. So I have the first and the last term. I don't have how many term numbers there are because of that ... Okay, so I'm going to use the arithmetic sequence a sub 1 a sub n equals a sub 1 plus n times d times n minus 1. And I'm going to plug in everything I know and solve for n. So I know the last term, I know the first term, I know the common difference is 3, and then n minus 1, right? So, man, that's a plus, sorry. All right, so I'm going to solve for n. So I'm going to subtract 29, so that's 30 equals 3 times n minus 1. So I just subtracted 29 from both sides to get it out of the way. Then I'm going to push the 3 through, so 30 equals 3n minus 3. So I'm going to add 3, then divide by 3. So I added this 3. So n is 11. So I'm going to put 11 here, and then I throw that on my calculator, right? So on that one, I think we got 484 on that one. Okay. All right, so let me move this out of the way. All right, so the next one says use sigma notation to write the series to add 14 terms. So I'm putting it in this notation like number 18. So I have the summation from 1 to 14, and then I need the explicit formula right here. All right, so I can do that. So a sub n equals a sub 1 plus d times n minus 1. So I just need the first term, which is 49. I need the common difference, which is 5. So 49 plus 5n minus 5. So 5n and then 49 minus 5 is 44. All right, so 5n plus 44. So I have 5n plus 44. All right, and then you could just leave it like that. That's it. Throw this in parentheses. So that is sigma notation. All right, to evaluate this series on 18, you can either plug in 1, 2, 3, and 4 to this formula and just add them all together. The shortcut on this, though, remember, is to use this sum formula, right? So I'm going to use S sub n equals n times a minus 1 plus a n times a sub 1 plus a sub n over 2. I know the term numbers. I'm starting at 1 and stopping at 4, so that means I'm plugging in 1, 2, 3, 4. So that's 4 terms. First term, I plug in 1 to this expression. So 1 plus 4 is a sub 1. So 1 plus 4 is 5, plus the fourth term, a sub 4. I'm going to plug in 4 to this. So 4 plus 4, and that's 8. over 2. So 4 times 13 over 2. You can throw that in your calculator, or I can reduce the 4 and the 2, and that gives me 26 when I sum those up. All right, so 26 for 18. All right, 19, what are the solutions to the following system? I did this by elimination, so I multiplied the top equation by -3 to get rid of my x's. So I get 3 minus 3x minus 6y equals -30. I get -3x plus 6y equals 11. When I add these together, notice everything goes away on the left side, and I'm left with 0 equals -19. That never happens. So when all the x's and y's go away, either it's no solution like this one, it never happens, which means when I graph my lines, they're going to run parallel to each other. Because there's no solution, they never cross. So if you put these on Desmos, they're not going to cross, they're parallel. So this is no solution. If I end up with 0 equals 0 down here, it's infinite solutions because it's the same line. So when you look at your answers, if you're like, oh, 0 equals 0, always true, that means all points are in common and it's the same line. All right, so I'm going to write that down here. So if I end up with 0 equals 0, so if this had been positive 30 and I ended up with 0 equals 0, I have the same line. So I have infinite solutions. Okay. We didn't get this page, so I'm just going to give you a hint. There's not one like this one on there. Just a hint. Okay. And there's not one like this one on there. Just another hint for you. Okay. All right, we will work one like this one because you probably will see that one again. And number 23. So if you want to try those out, you can. There'll be extra practice from what we talk about in class. All right, last one. All right, solve the system by graphing. So remember, this is what we played capture the flag with. So y equals -3x minus 1 and y equals 3x minus 2. Those are the ones we're going to graph, right? So the first one, my slope is -3. And my y-intercept is -1, so I'm starting at -1, and I'm going down 3, right 1, and go up 3, left 1. I'm connecting them with a solid line because there's an equal to down there. I'm going to test 0, 0. So 0 is less than or equal to -3 times 0 minus 1, so I went back to the original to test it. So 0 is less than or equal to -1. That is not true. So I'm going to shade on the side that 0, 0 is not on. All right, now I'm going to graph the second line. So slope is 3, y-intercept is -2. So I'm going to start at -2 and I'm going up 3, right 1. Oh, it's a dashed line, of course. Here we go. Dash that line. All right, now I'm going to test 0, 0 again. So 0 is greater than 3 times 0 minus 2. 0 is bigger than -2. That is true. So for the blue line, 0, 0 is right here. So I'm going to shade this direction. So you can see where I have shaded twice where the green and the blue overlap. So all in this section right here. All right. So if you have any questions, let me know. Not one like this on there. Yep. Okay, so I will see you guys soon.